All right, guys, where's everyone? Class clear. All right. So today we are going to switch gears a little bit from transfer learning and large language models to transfer learning and images. Okay, so we're still going to cover some of the topics of like PPO and things like that, but usually after spring break, I'll introduce the other big transfer learning area, which is going to be image systems. There, we're going to focus on fast AI today. So it's a library, but it's a similar idea. You have pre-trained models like ResNets, VGGs. Today, we'll use a ResNet. Um, and so we use the pre-trained model and then we fine-tune it on our data. So I have a couple of examples today. I'll start with that. And then the ideas are the same of transfer learning. You train the model, get the weights, and use those, except that the medium is images, right? So we'll take a look at that. All right, so let's get started here. I'm gonna go to 5:30. I'm going to cover content. Sorry. Okay, so we are fine-tune transformers. Pretty sure we covered that. Yeah, the two models. Unfortunately, I don't know if you noticed, but this video, the last fine-tuning of the GPT did not save, and I lost that video, unfortunately. So hopefully you attended class. The script is there, but I lost it. Sorry. I was not able to load it on. It's the only video I've lost. Something happened. Maybe I just forgot to hit record, to be honest. But anyway, so we pretty sure we've covered that. Um, So fine-tuning of transformers, and really, you have the whole idea. So we fine-tune a GPT, a BERT, and I did examples of RLHF. You guys are doing that third homework assignment, which is the presentation of RLHF. So yeah, so everyone just shut up. Did you guys have an exam or something? Huh? Oh, okay. Yeah. And yeah, so I was saying to everyone that we've the big two topics in this area are, well, the main idea is transfer learning, pre-training the weights, fine-tuning. We focus on large language models whole semester, and there's still a few ideas there that I need to cover. But essentially, we've done the fine-tuning of a GPT, a BERT. We've used it for inference quite a bit. And RLHF is really the culmination. So that homework 3 that you guys will be presenting is the sort of the end of that road. And I've already done a demo in class, but you guys are doing your presentations. So now it's time to shift gears to the other big elephant in transfer learning, which is images, right? And this one should be easy now, right? So we're going to look at image transfer learning. The library that I'll be using to start with is FastAI, and it should be pretty easy and straightforward. Okay, so similar idea like Hugging Face, right? So Hugging, we can do a lot of these things in PyTorch, but we use these even more higher level frameworks. So in large language models, mainly we've used Hugging Face. In images, I'm going to start with FastAI with the basic ideas. Although there's transformers for vision, I mean, everyone, so there's some overlap between things, obviously. So I was saying that we're somewhere around here, these modules. I do want to remind you, you can see it right here. Next Wednesday is exam 2. All right, make sure you're studying for that. It's going to be cumulative. That means everything from beginning of the semester until what we covered today. Similar format as the first exam, and it's closed notes, but you're allowed your cheat sheet. Any questions about the exam? So it'll be during the second half of class next And then during the first half, I'll just lecture some. Got it? Everyone with me? So right now, at this point in the semester, we have about 4 or 5 weeks left, right? And then exams, final exams. So what's left, if you want to know, you got to do your RLHF presentations and submit that. Then there's going to be a homework on images. So it's pretty easy. You'll just fine tune on your own images. All right, using a ResNet or something like that. So that'll be a homework. Probably the last homework and then the term project. And for the term project, had we talked about it already? A little bit. What did I say? Do you remember? Open-ended, yeah. That's essentially what it is. You know, you guys, I mean, some of you have taken 365 to 520, 530. You've taken a lot in Professor Kim's courses. So you've taken a lot of courses. So this is the end of the road, so to speak, right? For your masters or whatever. And so go ahead and just pick a topic. You know, you can start now. I would suggest, since it's a term project, groups of 2 would be a good number, right? So that everyone works really hard, but don't just do an individual one. You can, but I would suggest you work with someone and just pick something. Hey, build a company and I own 10%. But just do something that you want to do. I leave it to you. You can discuss with me, and yeah, could be language models, could be the common theme, obviously, because of this course, transfer learning. Take advantage of pre-trained, fine-tuned models. Make sense? So I leave it open-ended to your creativity. It is worth a lot, 20% of your grade, so it should reflect that. So it should be something substantial. Good. Got it? All right, great. So again, please don't forget the exam a week from today. And as you can see, here we are now, fast AI. This second sequence is the image-based stuff. There's a lot. There's a lot in this area, and I don't think there's enough time for all of this. Certainly. So I will start with like something that gives you a lot of power really quickly, which is the problem you might want to solve is you have an image classification problem and you know of whatever kind, and you want to use a pre-trained image classifier and just fine tune it on your data. Do you guys see that? So I'm gonna actually motivate this with 2 problems from cybersecurity. Well, one is from cybersecurity, but it should be pretty interesting. And we're gonna do that in class today. Make sense? All right. So I'm gonna do that now, and then I'm gonna leave these. I have these. So these fast AI examples that you see here, they're just inference. Just like how we started with large language models, we were just using the model and nothing else. I'm not going to start with these today just so that I can get to the more important topics. And instead, I'm going to start with fine-tuning a model. Okay. But these are pretty easy. And they're with fast AI as well. After that, there's obviously foundations of computer vision, and I may skip that topic given that you guys have already taken more, the other courses. And then after that, as you can see, fast AI pre-trained image classifier on your data. That's kind of the topic that I'm covering today. And then after that, there's little individual things like data loader with your own data. I might do the object detection one because it's a specialized library called YOLO, which it means something like you only something once. Yeah, you only live once. Yeah. So yeah, exactly. So it's got a funny name. But yeah, so it's a really good object detection system, and we can use it as is. So it's inference also. So that one we'll get to at some point as part of the inference ideas. And then, yeah, ResNets we'll cover a little bit today, and I'll cover them in theory as well. We've covered, so if GANs and stable diffusion is covered in 520, the algorithms. Here, what I like to do is to cover a topic called, a more advanced topic called style transfer. So it's where you take a picture that you have and make it into a Picasso, make it into a Monet, those famous painters. So that used to be very novel. Now with all the tools that we have available, you could probably just do it on your phone, but it used to be that was a variant. But I'll talk about how it works. So, and we'll do it in more lower level. All right, with our actual code is what I mean. So these are papers that exist. But anyway, that's kind of what's coming up. As I said, that's it. That's the semester. So I want to start here with this one. I have like my example from last semester, and I've left it here. This one, but I have two new examples this semester that I worked on, so I kind of want to start with those, and I think they're a little interesting. So we'll talk. So a lot of you like cybersecurity, so I have one related to that. So to give you a good insight into that. All right. So the links. So I'll provide the links. So cybersecurity and machine learning here. This is a new problem I've developed. So it's here, software assurance. Yeah, so I'm just going to copy this whole. So I'm going to call this malware. Create a. Say malware and CNNs or ResNet maybe. Yeah, and it's going to be the files in here. And I have another problem, which I call adversarial learning, but it's also essentially image training. So I've just made some more elaborate problems. So that's going to be here. I don't know that we'll have time for all of these today. So that's here. Okay. So this one I'll say adversarial fast AI. All right, there we go. All right, so these are the two links. The data is provided there. All right, so we're just going to use them, play with them. Okay, so let's go ahead, think about this. I'm going to go back to table of contents. Fast AI pre-trained image classifier with your data. All right, so we'll start with malware and ResNet. Okay, so what's the idea there? So I've mentioned to you that I'm going to show you how to take an image classifier and fine tune it with your own data, right? That's kind of and then I'm also saying malware. Malware is what? What is malware? It's like a computer virus, correct? Yeah. So what is a computer virus? Essentially, it's a program code, but piece of code, right? Yeah. And usually it's like a .exe file. For instance, let's consider just Windows, the Windows operating system. So it's just an exe. You double click on it. It's binary code, right? And it just runs and it'll do bad things, correct? So imagine that I'm saying that that's the data, yet I want to use an image classifier, right? So how is that even possible? So what I'm going to show you today is that actually you can leverage CNNs and image classifiers for other types of problems, even things that are not images, because you can just take the data in that other medium and represent it as an image. That's really the key. Do you guys see that? So we can grab essentially, imagine you have an exe file, right? A binary file. What is it really? It's hexadecimal characters, right? And those hexadecimal characters are essentially what? ASCII individually, they're ASCII characters. Do you see that? And ASCII characters, if you go to the ASCII table, are essentially what? A number, a decimal number that's actually between a small range, like from 0 to 255. Do you see what I'm saying? So essentially what you can do, the trick is you can take an exe, and I have all the code, so I actually should click on this. So you have, all the files there, and you have some kind of an exe, which is a string of hex values, and then you can just convert those into the equivalent ASCII numbers, and then given the size, just make it into an image, just like reshape it into an image. And that's the trick. And then see how it does. And as it turns out, it may do okay in the task, in the problem. Do you guys see what I'm saying? So obviously in this folder, I don't have any computer viruses. I would not include that for you to download to your computers. So there's nothing like that. But there are basically what I do have is goodware, if you will. So you go to Windows and you grab exe files, right? But just grab like calculator or notepad or something. That's the same as a computer virus, only obviously it's not going to do any damage on your computer. So think of it that way. Okay, so I have then code here, essentially, to convert exe to images, right? So an exe file to images. So you can read, it's not a very long function, but essentially it's going to be something like this. So you're going to read, and really, you're going to read byte array. You see this? So you read the file, you read the file that you're trying to grab, either the exe that's goodware or the exe that's malware. You read it in, right? And then once you read it in, you convert it into a byte array, right? And that gives you the information that represents it as a sequence of numbers. And then if you notice over here, all you do is an NP reshape, where you now specify that you want the exe to be of a specific file. You can, maybe crop the end or whatever to fit your dimensions or do padding. It's up to you, but you do want it to be maybe like a square image. That creates this variable g, and then you just run it through a uint8 and ensure the data is between 0 and 255, which is the scale of the values of a grayscale image. Do you guys understand the process or the trick? This is literally a trick, right? But what I'm showing you is here that you can use image classifiers, which are really good for many, many other things, as long as you figure out how to convert that data into an image. And in this, because you might have patterns in there, and that's essentially what the CNN is trying to find. And using a ResNet means that it's really good at finding, detecting certain things. And then some of the layers do a lot of the heavy lifting, finding some of the semantic relationships. And then the final layers will take that output and map it to the classes of your problem so that you can build a classifier. Got it? So that's the idea. So you can see here, there's a lot of code on iterating through there's libraries, iterating through the files, but essentially, this is the trick. You read the file, convert it into a byte array, reshape it, given the width that you have, and then just ensure the data is between 0 and 255 by doing a typecasting here, such as uint. After that, this G just becomes an image. So you can go from array to image using pill, and then you just save your images in your library. Okay, so if you want to try this out, again, I don't recommend that you do this with a computer virus, but I did provide another script which should be get exes from Windows. So you can try this one for fun, I guess. You run this script on any Windows operating system, and it's going to find some exe files in there so that you can save them in some folder, zip it, and there you go. All right, so you can do that as well. I already took some of these, converted them to images, so I wanted to demo just that part, but I wanted to motivate this idea. All right, so here we have, so it should be this. So I've shown you convert. So essentially the process is get the exes, whether goodware and malware, put them somewhere such as, a folder, and then convert the exes to images, save those into an image folder of goodware and malware, for instance. And then obviously this would be the fine-tuning code that we're going to use. So we're going to assume in this example that all that has been done, and I already have a few images. Okay. And I think I skipped a part. So actually, I'll go back to this Jupyter. And once the images have been created, then you can see here. For instance, I created this from an exe, this PNG. And then when you read it, you can see to us, it's meaningless. But obviously, machine learning has advantages sometimes over people. And so the idea is it's going to look at this in the class and essentially try to build a classifier for computer viruses, but treating the computer viruses as converted images that are black. All right, great. So anyway, I put together a little list of images, just very small folder, just so that so that we can see it running and get the code to work. So it should be these malware image data. All right, so I'm going to download these. Okay. It should be on downloads, I think. Should be, yeah, this one, malware image data, copy. So now I'm going to go, I think this is our folder for the semester. Should be fine tuning RL. So I'm going to create a new folder here, and I'm just going to call it Fast AI. Fast AI is pretty much like Hugging Face, just wrapper code around PyTorch, essentially. So we're still using PyTorch, things like that, but just with these abstractions. All right, so in Fast AI, I'm going to add the folder. I'm going to unzip it. Okay, so you can see we go to Fast AI, and then we can take a look here. Double click on that. Got some images here. And I'm actually going to copy this. All right. Let's go back. All right, so this is the folder, and you can see basically you need to have the folders for each class. That's how this code is going to work, which is usually how it's a good practice. So if you're doing steganography, steg, not steg, right? If you're doing apples, bananas, pineapple, however many folders you want to have, just label them and then put your images in there. All right, so you can see here, I have some examples of images. They're all PNGs, and you can see they are a little bit different, right, in their appearance. There you go. All right, so now, as I said, for something like this, I don't want to use for liability things, malware and things like that. So there's no malware in here. Essentially what I did is I just took some goodware files and I put some in goodware, some in badware, and it would be up to you to replace these with actual malware. But this will show how the basic structure of this. And then I do have other examples where I have the apples and pineapples. All right, but I wanted to start with this one because I thought it was fun. All right, so anyway, the point would be that hopefully the goodware and the malware obviously would have differences, right? So there would be something, I don't know. And then given that, the classifier would pick it up, but especially it would be really good because it's using a pre-trained model such as a ResNet or something. It could be that there's also a pre-trained model for this. Think about that, right? So there could be maybe there's a pre-trained model for hexadecimal data in computers. You use that, right? Or something. Anyway, lots of things to do there. So now we've created the data there, and so we are ready to look at our Jupyter notebook and then kind of just try to replicate this example, and do this exercise. So I can show you essentially what my goal. You guys understand the theory of this, and my goal is really just to show you how you can build a very powerful classifier really quickly. So let's go ahead and go back to our GitHub, or sorry, to Brightspace. So we go back to Brightspace. I'm going to click on malware and ResNets. Right? And we've looked at the files. Now the new file that we're going to look at is fine-tuned malware model images. All right, here we are. So let's look at it first, get a feel for it, and then after that, we can try to implement it. So we've got a whole bunch of libraries, as usual, pill image, which is familiar, but now, obviously, the new one is Fast AI. All right, so Fast AI, like I said, like Hugging Face, kind of more focused a little bit towards images, although it has other capabilities. Well, some parameters there. It's got its own specific format of, creating the data loader. So it's got its own loaders and data loaders, and it's got a specific format on how it works. And then, we'll read in the image data, show it essentially. We build the train model, train function, and we train. See how fast it is. So, a lot less code, and then we can, look at the losses. We have a nice confusion matrix and print the results. So in very few lines of code, you're up and running as long as you put your data in the specific format. Okay, so that's kind of the idea. So let's go ahead and get started. So I'm going to this probably would work on like Python. I'm going to try a 3.7 maybe. Let's see. All right, so we're going to open up Anaconda, of course. Like I said, you will have a homework assignment on exactly this. So just get your own images for something. So Anaconda prompt. there we are. So we're going to go into the desktop. Yes. 5:30. 2025 spring. PIR. Fast AI. PIR. All right, so our data should be there. So this is where we can put our Jupyter notebook. So let's look at an environment, Conda environment list. Okay. Okay, Pi 3720. No. I have a fast AI environment already in there. I'm gonna activate that one. Conda activate Pi 38 fast AI. All right, let's try that one. All right, let's do Jupyter Notebook here. To create, probably pip install fast AI. Okay, that's probably all you need. But let me know if you're having issues or if you've done it already also. All right, so here we are. Okay, so now I'm going to create a new. Okay. All right, so let's try this. Okay, so this is our example. So let's grab the libraries and see what's missing. Also, I'm going to rename this as in class. Call it malware. Whoops. Right. So let's run it. Let's give it a minute there. I don't think we need this Colorama one, so we can comment that out. All right, great. So in my case, I had all the libraries in this environment, but like I said, if you don't have it, probably pip. Right. So you can comment that out. So just put we don't need it for this, I don't think. And then pip install for fast AI should work. Okay. Got it? All right. Let's proceed. So that cell worked. Raise your hand if you have questions, guys. Okay. All right. So then just some yeah, so load truncated images, change the max pixels to avoid warnings. Let's just use those. It's default settings. All right. And then, so load the data. This is it's kind of tricky. You got to get used to it. It's how fast AI does things. They have their own ideas. And so essentially you create a function, load data, you give it the training path, the validation, batch size, none, get items. You provide a function, get image files, which is get items here. And this is how it extracts the data. So it's trying to make your life easier, right? So then it has created this flag that's called get items. And it's supposed to receive a function that is designed to grab your data from your folders and process in some way. So that's kind of how they approach that. Okay, so that's why you see here we're passing this function get image file. Also the label get y, so that's going to be parent label. Get y is this get y. So that's the same idea. You know, how do we process the labels efficiently? Pass a function to it, define that function, and FastAI will almost magically get you the labels. Do you see that? So that's essentially how it works, which can be hard, right? I can see if you're seeing this idea for the first time, but you just get used to it. You just have to understand that it's expecting that. All right, then item TFMS is the resizing of the images. The 224 is because ResNets are expect images of that size. Okay, so you resize method, use padding, and then batch TFMS, augmentation transformation. So when you have an image and you kind of like augment the view of it, you flip the image, etc., just to provide more diversity. All right, so anyway, that's so parent label, you can see here is described, simply gets the name of the folder a file is in. So that's and this parent label, let me take a look here. So we have, here's the ResNet 50. All right, so we'll probably describe it in a second. So we have our loader, this object. Now, this is the tricky thing here with FastAI. As you guys have learned by now, the hard part is not the model when it comes to transfer learning, right? What was the hard part in Hugging Face? The data, formatting it, putting in the right, same goes with the image. A lot is going on here, right? So you have this function for the labels, this function for the images, and then you have this thing called blocks. And there's a lot of these blocks. They're essentially like a data structure for the problem you're trying to solve. Do you see that? So for instance, there's a block and then you provide this sort of tuple where this side here is like the image, the image data structure, and then this is the labels data structure. But you can see you're saying it's an image block and it's a category block. It could also be, for instance, a regression block. If it's a regression block, what does that mean? That the value is not a label, but it's something like a temperature or something like that. So this is how it works. And there's, like I said, there's a lot of these. So you can look up your problem. So for instance, there could be one that's image block to image block. Do you see that? So input is going to be an image block, output is an image. Input is an image block, output is category block, input is an image block, output is a regression block, and so on. Right? And so you just got to look up the thing. One of the most common ones is this one, obviously, because it's a very common problem. Give it an image, help me classify. That's how it works. Okay. Any questions about that? Right. So all this is doing is processing the data in the right format with these approaches. These are very unique to the people that created this framework. But yeah, so that's what they did. Then you have you invoke loader here and dot data loaders. You give it the train path and the batch size that you're specifying, and all the other parameters have been defined already here. So when you import, I believe that what happened is because you don't see them here, right? There's OS warnings, pill, but here we say from FastAI Vision all import all. So we've imported everything. So these are built-in functions in FastAI. So for instance, that's why parent label, it says parent label simply gets the name of the folder of a file the file is in. That's it. That's all you have to do. So if you put your images in folders and you name all these folders as the label, then that's all you have to do, and the loader will know exactly what to do. Got it? So that's essentially how it is. And then this one just gets image files. So the images are files, and it's going to get them. Anyway, so we define just two parameters, define the path, obviously, and then we create a DLS. And that's our data loader, but in a FastAI context. All right, so we can proceed. All right, so that worked. Then the next step is, I'm going to save this one. All right, so we've done that. And then now we try to read in our data and view it. So the path here, I believe the images are just in malware image data. So they're in malware image data, just like that. That should be the folder, malware image data. And then we provide that as train path. And you can see here we specify parent label and batches of 8. And then validation percent is 20% versus train, 80% train. So let's go ahead and run it. Okay, so it's trying to read. Could not do one path. There's something wrong. Okay. I want to say this is a Python 3.8 error. Certain that's what that is. Give me a sec. So I'm going to use that 530 from 2024. Conda activate 537 530 2024. Okay. Do Jupyter Notebook. Okay, we're going to try this again. All right, we're here. All right, I'm going to restart the kernel. Okay, run. No module fast AI, so now I'm going to have to install it. Did pip install fast AI work for you guys? The ones that tried it? So you don't know. Nobody tried pip install fast AI? Right? I believe it's fast AI. Let me submit. Let's in there. So where were we? So we were loading the data. While it's doing that, let's keep going. Right after we load the data, we'll want to show it from the DLS so we can use that object. So we would show from the validations from DLS validation set, show a batch of about 8, and we just plot them. They should look like this. So as you can see, there's actually one example of bad. Remember, these are all technically goodware, but they are correctly labeled, right? So we've added images with their appropriate labels. You can see some are bad, some are good. So that's the data that we have. And then essentially the next part will be to just create a function called train model, given that our data is already correctly classified or formatted. Here we need to provide things at DLS, which is the data loader from FastAI in the FastAI format. We need the actual architecture. So we just use a keyword like saying ResNet 50. We need the path to where the trained model should be exported, the number of iterations, the metrics to print while training, pre-trained, whether or not to use a pre-trained model, right? So in this case, if it's false, you create model from scratch. So this is when you've already trained and you want to add more training, right? So in this case, yeah. So whether or not we to use a pre-trained model, create or false equals to create model from scratch. Obviously, we are setting the flag to true, which means we use the ResNet's weights. Does that make sense, guys? That we're using? Okay. And so, man, this thing is not cooperating at all. Right. So anyway, so the parameters for the trained model, DLS, the architecture, the path, um, number of iterations, the metrics, error rate and accuracy, pre-trained model, true. And then essentially here, this is like the key aspect. In one line of code, we instantiate the model. So again, when you did from FastAI import all, you imported something called the CNN learner. And the CNN learner is essentially in FastAI they call models learners, right? So so you'll have various kinds of learners, but in this case we're using a CNN learner to instantiate a CNN type architecture. You say DLS, which is the data set, and then arc. Remember, this arch is going to be ResNet 50. This is just a function. Once we call this function, we will plug in ResNet 50. We have the metrics, and as I said, pre-trained. And once you do that, you've created your model, and then you can start fine-tuning it, essentially. Nobody tried this, installing FastAI? Did it do it? Did it take forever? What's that? It's like saying it's required. 3.9? Oh, really? Oh, okay. So here is error. So 3.9, huh? Okay. Let's do that. Right. And deactivate. Conda environment list. So I have one 3.9, which is RLHF. I'm going to try that. Chef. All right, so we're going to try this. Again, we're there. So now Jupyter Notebook. See what happens. Okay, let's install it. Oh, actually, I meant to. Well, anyway, run that. Let's wait, I guess. While it's doing that, we can go back to it. So in the train model, we create, as I said, we had created the CNN learner, and that's our model. And then you can see, uh, we can apply this function called learning rate find so that it finds some kind of an optimal learning rate. It does some grid search, one of the grid search approaches, and it finds some kind of a learning rate. So this is a functionality that's provided in FastAI. Then that base learning rate can be provided here. You also provide the number of epochs, and essentially you fine tune the model, right? So that this is the training. Notice there's no opt, no step, nothing, right? So it's all doing it at a high level, but it should do the fine tuning. And then, so these are probably the, let's see, this is fine. Yeah, that's doing the training, fine tuning. And then it's passing, notice the data from the DLS train and validation into the actual model, which has also these two. That's probably to do some evaluation later. And then the model is exported. So means you save the checkpoint somewhere in that path, and that's it. And that returns the model itself. Man, this is still going. Yikes. Okay. And then after that, once it's finished, we would essentially start the training process. That would be this here. So we have the file to export, best model, right? So we export it. And then notice we have train model. So we provide DLS. Here is where you specify that you want ResNet. Notice this is also a keyword from FastAI. The export path, which is this one here, 10 epochs, the metrics, and you want a pre-trained model. So all of that is given to train model, and it should return our model. All right, let me try Colab for a sec. I'm just curious at this point. How long does it take to install FastAI? Use cells here. Let's grab the runtime as T4 GPU. And let me just try that again. Pip install FastAI. Maybe I'm missing something. It worked? Okay, perfect. All right, you can see actually Colab is being more responsive here. Oh, okay. My laptop did something. Okay, successfully. So finally, right? It ended. All right, so that's good. So let's try it again. We're going to try to load the libraries. This Colorama, I don't think we need. Hit run. Let's give it a second there. Colab is still going. Nope, successfully. Okay. It's still processing. Did something else. Still doing. So let's go back here. So this libraries are still loading. So you can see it's a pretty big set of libraries, right? It's kind of what I say. Even in Colab, it's kind of slow. Okay, here's the green check. So I just want to try the libraries now, just curious. There. Okay, so it finished. Good, right? Finished. So this seems to have worked. Process, process that, process that, process that. Did we ever? Okay, there they are. So as you can see, these are the actual images, good, bad, etc. Right? Everyone with me? So yeah. So basically, the data loader, a little bit getting used to, but you load it here. Then you have your train model, which has already been added, and then essentially run the train model on a ResNet 50. So I only see, it says user, I see a user warning, has been renamed Vision Learner, but it's just a warning. Just give it a minute. Okay, good. Essentially, hopefully it'll start. You can see it's starting the training process, and it should do this. When I ran this script, the training loss does seem to go down from 146, 118, 120, all the way to 104, 105. You see that? So that's what you're looking for, and it's providing accuracies, etc. This is the learning rate that it found to be optimal. And then here there's a confusion matrix that allows you to measure performance. So performance is not great in this one, but remember that these are all of the same type. But that's it. That's literally it. After you finish the training here, you invoke confusion matrix and you provide to it this function confusion matrix and you provide the model itself. And now it's going to go in this function, it's going to evaluate performance. So you just give it this magical function here, classification interpretation from learner model. Remember, we had given it the train and the test set, right? And it's just going to do everything for you. That's it. So essentially, this is a long function, but only these 3 lines of code are running, and that's it. Does that make sense, guys? So it's meant to be super easy, right? So if you see the common theme here is making this more accessible to everyone. So even people that have never used PyTorch but know Python could use something. It is very powerful, though. I mean, to be able to do this, you can definitely, if you have an image classification problem, using something like this with a resident 50 is, kind of state of the art. I mean, it's good. It's good. All right. Yeah. So that kind of concludes this example of malware with images. Obviously, I'm running it on CPU here, so it's going to be pretty slow, as we can see. So now, what I want to ask you guys, you guys have started to use Colab for your RLHF homework? Hmm? Mhm. Mhm. Yeah, let me pause this, I guess.